quadratics.
Okay.
Today I learned the quadratic formula, which was pretty easy because I learned that in Algebra 1.
Okay.
So now she
don't read it off of a piece of paper. Tell me what it is.
Okay. It's in parentheses 2k plus 4.
Oh, whoa, what? Oh. No, I meant what the quadratic formula was.
It's x equals negative b plus or minus the square root of b squared minus 4ac.
That it?
All
over 2a.
Right.
Okay. Now, go ahead and give me your problem and we'll try to solve it.
Let's see. Okay, it is 25x squared minus 18x equals 12x minus 9.
Okay. What should we do here?
Probably move 12 and 9 over to the left side.
Yes, whenever you have a quadratic in standard format, that's almost always, in fact, I can't think of a situation where you don't want to do that. And leave 0 on the other. Now, this looks like it would be a hard quadratic to factor, but it turns out that it's not. It's relatively simple. And remember, my suggestion is that when there are multiple factors of a number, always start with the factors that are closest together. In other words, I have a choice here. I can break this up 5x and 5x, or I can break it up 25x and 1x.
Okay.
Well, this is a trial and error process, but this is my first try. I'm going to do 5x and 5x. Now, what are both signs?
What do they multiply to?
No, the second step in factoring is always figuring out your signs.
The sign. I thought you said that.
First step, we broke up the x squareds.
Right.
Now, what do both signs have to be?
Well, one has to be a negative and one has to be a positive.
No, that would not produce a plus 9.
Oh. So they
both have to be the same, and because the middle term is negative, they both have to be negative. Notice that whatever numbers go here, this last term, after you multiply these two together, comes from this number times this number. So when you're factoring, when you're trying to go in reverse, the best thing to do is figure out, well, what signs do I have to have here? And that makes the problem a whole lot easier. Now, we want factors of 9, and there's only 2 factors of 9, those factors there. Which one should we try first?
Probably 9 and 1.
Oh, which 2 are the closest together? 3 and 3.
Okay.
Okay, that's what I mean by when you're doing a trial and error factoring problem, always try the closest ones. I'm going to put a 3 there and a 3 there. Closest together. In other words,
what do you mean by
3 is closer to 3 than 9 is 1.
Okay.
Okay? If I was trying to factor 15, okay, well, there's 15 and 1, and there's 5 and 3. I'm always starting with that. because 5 is closer to
Okay.
3 than 15 is to 1. That's what I mean by closer
Right.
together. Okay? It's just that almost all the problems they give to Colorado students use factors that are the ones close together. Now, there's one method of checking to make sure I did everything right. Okay? Now, I don't have to FOIL this whole thing back together again. I could, and you would see that I have 25x squared minus 15x minus 15 more x plus 9. The thing is that because of the way I factored it, I'm 100% sure that this term is correct. And I'm 100% sure that this term is correct. The only term I really need to check is this middle term, which is produced from the O and the I of FOIL, the inside and the outside. Multiply the insides together, multiply the outsides together, add them together, and see if that's the middle term you're looking at. And that's the only check I need to do. In other words, if my life depended on it, I might go back and FOIL it properly. But if I'm doing a problem on the test and speed is an issue and I got more problems to do, then I'm just going to do this inside and outside check.
Okay.
And in fact, that inside and outside check is actually part of the process. I didn't know that 3 and 3 were correct until I did this. Right? In other words, I had no way of really knowing that 3 was the answers. I tried it because they were closest together. If that hadn't worked, I'd have then gone back and tried 9 and 1. You with me with the strategy?
Yeah.
Okay. Give me another one.
Okay. It's 4 parentheses x minus 1.
I didn't quite hear your beginning.
Oh, 4. And then parentheses x minus 1 squared equals 6x plus 2.
Okay. Our first step.
Probably to expand the x minus 1 squared.
Yeah, there's really, there's no other way around it. Sometimes there is. That isn't always the next step when you see something like this squared. In other words, if I was, just as an example, let's say I had this. Okay? My next step would not be to expand that. It would be to take the square root of both sides.
Oh.
And I would have this. And then add 1.
Okay.
Well, it's actually plus or minus. And then add 1 so that this is the answer. Okay? So just because you're looking at something squared doesn't necessarily mean you should do it. It just depends on the context of the problem. The problem here is that if I try to solve it that way, I'm going to still have x on the right side. And there's no way it's ever going away. So when you have an x squared and an x, you usually do have to expand it. Okay, expand that for me. Just that part right there. Anna, you still there? Feels like the sound cut out. Anna, you still there? Are you back?
Call has been forwarded to an automatic voice message system.
Anna? Call my phone. Anna? Hi, Anna.
Hi.
Looks
Sorry,
like
my computer kind of just like shut off and plugged in, and then I can't turn it on right now, and so I'm just going to try on my mom's computer.
Okay, I was going to say, if you can always pull the plug on your computer and then plug it back in after waiting like 10 seconds, and that generally almost always will get it to reboot. But if you can do it on your mom's computer, that might be the better way.
Yeah, because I know my mom has audio too. Huh.
Well, even if she doesn't have audio, we can always use the audio from my phone, like this. In other words, all you need to be able to do is to get into GoToMeeting with or without audio, and we're fine. Okay. And in fact, on some of these problems, we could almost do them strictly by phone. Certainly the ones you're giving me now, although I hate doing that. It's just, I don't think it's quite as effective. But so it's better if you try to get on with your mom's computer. You want to go do that now?
Yes. So
I'll hang up with you, and I'll use the same meeting ID number.
Okay.
It will let you log into this same meeting. And if you have trouble, or if we have trouble with the audio, call me and we'll use the phone for the audio.
Okay, and I go to gotomeeting.com?
Has she used GoToMeeting on her computer, or do you have to start from the scratch?
No, I have to start from scratch on her.
Go to joingotomeeting.com.
Okay.
Joingotomeeting.com. Okay? And then it'll ask you to install it. Go ahead and install it, and then log in. The whole thing will take about a minute, minute and a half maybe.
Okay.
Okay, yeah. It just told me you left the room. Okay, good. That'll make it easier for you to get back in, I think. So I will hopefully talk to you in a couple of minutes.
Okay.
If you have trouble, call me on the phone and I'll work you through it again.
All right.
Okay, bye-bye. Might try rebooting that also. Just unplug it for 15 seconds and then plug it back in. Okay, period. Can you hear me? You may have to unmute the microphone.
Hi. Sorry.
Okay. Are you sure that computer does not have a microphone?
Yeah.
Okay, cool. Does this work for you?
Yeah.
Okay, you can see my screen?
Yeah.
All right. First thing to do is to expand that. How does that expand? Expand it first. You don't want to incorporate that 4 in until you've expanded it, because that 4 is not being squared. Correct. Go ahead and multiply that out. What do you get? Having a little bit of a hard time hearing you. Oh no, let me turn my volume up just a little bit. Okay, that might help a little. Maybe, well, not really, not a lot. Oh, I need to turn the volume up on my phone, not my computer. What was I thinking? Hold on. Yeah, my volume's all the way up on my phone. Can you hear me okay on the phone? Okay. Maybe just kind of talk into your phone a little closer.
Okay.
Ah, that's much better, whatever you did.
All right.
So when you expand x minus 1, expand just that part. Don't incorporate the 4 yet.
Okay.
So what do you get?
X squared minus x. Oh, wait. Is that right?
Depends on how you're doing it. That's not the final answer. It's minus 2x.
Oh, right. Okay. So minus 2x.
Hold on. Here, let's go back and do this. X minus 1 times x minus 1. Foil it.
So x squared minus 2x minus 2x.
No, minus 1x minus another x plus 1, which gives you x squared minus 2x plus 1. Okay? Now, it's actually a really good idea if you figure out how to square things without having to FOIL them. In other words, a minus b quantity squared is always a squared minus 2ab plus b squared. That's a quick way to do it. And it's useful in the sense that you have to do this so many times. You might have to do this 1,000 times over the next 2 years. That to have to FOIL it each time is a waste of time. You're much better off if you memorize these two formulas, a minus b squared and a plus b squared. A plus b squared, the only difference is that the middle term changed to plus, everything else is the same. Okay, so what goes inside here is x squared minus 2x plus 1. Now we need to apply the 4. Notice why we could not apply it before then. The 4 wasn't being squared. If we'd have put it inside, and you can't really distribute that 4 before squaring that. Now we got 4x squared minus 8x plus 4. Let's bring those two terms over and simplify. What do you get?
4x squared minus 14x minus 2.
Plus 2, I think. Okay, what's the next step? Always think greatest common factor as a first step. Is there a greatest common factor that I can take out of that? What is it? What's left? No, it would be 2x squared minus 7x plus 1. When you factor out a greatest common factor, what you want to do as your very next step is to always be multiplying it back to make sure you haven't changed anything. We didn't change anything, right? In other words, this expression is exactly the same as that expression. If And the way to determine that is to be multiplying as you're doing it. In other words, I wrote 2x squared there because I knew it had to be 2x squared. It's the only way I'm producing 4x squared. Okay? So now I can divide both sides by 2, and I'm left with this. And the reason this is superior to this is because it's smaller numbers. In other words, it didn't really change anything. I'm still going to have to use the quadratic formula, but it gave me smaller numbers to deal with, and that's always worth doing. In other words, I could have plugged these numbers into the quadratic formula, and I would have gotten the same answer. But you always want to factor out a greatest common factor, because I could not really tell, looking at it in this form here, whether I could factor it or not. It was only after I removed the 2 and examined what's left over that I can see that there's no way that factors. There's no way I can get to a middle term of minus 7x. Okay, so how do we solve this? If you can't factor it, what do? Quadratic formula. Quadratic formula is always the choice of the last resort. Tell me what A, B, and C are.
So A is going to be 2, B is going to be -7, C is going to be 1.
Okay, now what's that going to give us?
So x equals 7 plus or minus because you're -7 squared.
Make sure you use parentheses when you do that.
Okay, and then -4 times 2 over 2 times.
The 1, let's put the 1 in there just so we don't get lost. In other words, there's nothing wrong with doing this as your first step. Don't try to take shortcuts. In other words, there's no need to take shortcuts and start doing some of these calculations in your head. It's not worth it. It risks making mistakes too much. Now let's simplify. So what do we have now? Hold on, I didn't catch the first part.
Oh, well, the first one would be 7 plus the square root.
Plus or minus.
Of 49 minus 8 over 4.
Okay, let's keep simplifying.
And that'll be 7 plus or minus 41 over the square root of 41.
Okay, now can square root of 41 be simplified?
Well, it can, but
Not really, it's actually prime. So this is your answer. Those are your two answers actually. One answer is 7 plus root 41 over 4. The other is 7 minus root 41 over 4. Let's talk about simplifying radicals for a moment. Can this be simplified? Actually not. I can turn it into this. But that's not simpler, is it? That's two terms instead of one. So the only time you can simplify a radical is if you can pull a whole number out. For instance, root 8. Root 8 is root 4 times root 2, and that is a whole number. So I can simplify it by doing that. But that's the only time you can simplify, is if you can actually pull a whole number out. Any other time, you leave it as is, even if it's factorable. In our problem that we just had, we had square root of 41. Well, there aren't any factors of that other than 41 and 1. But here's a case where it is factorable, but it's still simplified as it is. In other words, you have to be able to find a factor that's a perfect square number for that to be simplifiable. Okay? All right, you got another one? Okay, I'm having just a little too much hard time hearing you when you talk.
Is this better?
Yeah, I can hear now.
Okay. So it says to use the quadratic formula.
Okay.
And the equation is x squared minus 4x minus 5 equals 0.
Okay. Now, this happens to factor. X, signs have to be opposite. Factors of 5 are 5 and 1. 5 goes there, the 1 goes there. That's plus x. That's minus 5x. Add them together, we get our middle term. So this factors nicely, and I wouldn't normally need to use the quadratic formula except for the fact that that was the instructions. So let's see if the quadratic formula gives us the same thing. Let me start it up a little higher. Maybe I won't have to scroll down. So using the quadratic formula, what do we get? X equals what? Okay, now let's stop for just a moment there. This one has a negative c, okay? And this is ripe for making mistakes. I give this problem to 100 people who are math students, half of them are going to make a mistake. And the reason is there's so many negative signs under that radical. So I tell everybody to do this part first, always. Come up with a number for that, not including the subtraction sign in front of the 4. Not including that. The reason is that, first of all, if you just were to do this problem normally, man, you're looking at 3 negative signs there, and only one of them means subtraction, this one. Okay, so it's just tremendously easy to subtract 4 and then subtract 5 again, accidentally. So that's why I tell C is very frequently negative, okay? So you're always going to have that negative sign in front of C, so let's do that first. 4 plus or minus, and we can certainly do the minus 4 squared, that's 16. But now we're going to subtract, that's minus 20. You with me? See how I ensured that I wasn't going to make a mistake. Now, that's 4 plus or minus the square root of 36 all over 2. And that is 4 plus or minus 6 all over 2, and that is either 10 over 2 or minus 2 over 2. So our solutions are 5 and minus 1. using the quadratic formula, which are exactly what I got. In other words, if I was doing this on a test, I'd do it this way every time, just because it's quicker, a lot quicker. But you get the same solutions. In other words, you get x equal minus 1 or x equal 5 either way. And it's certainly important to realize that you do. The quadratic formula works all the time. It's just that you don't need to use it all the time. You only need to use it when it doesn't factor nicely. Now, a lot of times there's a bit of a question as to whether how much time you should actually spend trying to factor it, as opposed to just diving immediately into the quadratic formula. Now, on this particular problem, they told you to use the quadratic formula, so there was no choice. But you may take a test where you get an equation and you don't know whether it factors or not. So you don't want to spend 10 minutes trying to factor it and then have to use the quadratic. So a lot of times there's a question as to which one to use first. It kind of depends on how good you are at factoring. Once you get a little better at factoring, it's easy to recognize the ones that factor and the ones that don't. Okay, I recognize this factored fairly easy, whereas, oh man, hold on. Never mind. I was going to go back to the previous page, but I don't know how to do that. So, all right. All right, what do you have next? If I sound like I'm hurrying, it's because I keep expecting some piece of technology to fail here any minute.
It's another quadratic formula problem.
Okay.
And it is x squared minus 16x.
16?
Yep. Plus 7 equals 0.
Okay. And again, I can look at this and immediately know it doesn't factor. Do you know how? It would have to be, if I tried to factor it, it's going to have to be x minus 1, x minus 7. And there's no way that produces a middle term of 16. And there's no way to make it produce 16. So I can tell very quickly that it does not factor. And I would spend no time trying to factor that. So that's not a bad skill to have, is knowing as quickly as possible that it's not going to factor nicely. So tell me how to do it using the quadratic.
Alright, so x equals 16 plus or minus negative 16 parentheses squared minus 4 parentheses 1 and parentheses 7 over 2 times.
Okay, now we can simplify that a little bit. That's 256, I believe, minus 28. 16 plus or minus the square root of 228 all over 2. Now, how can I tell if I can simplify 228? Checking, in other words, over here on the left, I'm going to write the perfect square numbers. With me? So we're looking for one of these to be able to divide into that. It has to have a factor that's a perfect square number. Otherwise, we can't simplify it. Well, is that divisible by, well, let's start with 4. Yeah, the way you can tell if a number is divisible by 4 is if the last two digits are divisible by 4. That's all it has to be. In other words, if I give you a number like this, that's divisible by 4, because that is. Okay, that's all you need to know, is that the last two digits are divisible by 4, and that's a nice thing to know, because at the very minimum, that lets me take a 4 out. Well, if I divide that by 4 and take it out as a 2, what do I get? I get 57, I believe.
Wait, why did you put 2?
Well, because here's what it really is. It's root 4 times root 57. Okay, that's the way I factor it, is I first break the number apart into two factors, one of which has to be a perfect square. And because that's a perfect square, I'm going to be able to replace it with a whole number 2. With me? Now what can I do?
You have to add 16.
There's one step I can do to still simplify this.
Can you divide all that by 2?
Yeah, I can divide top and bottom by 2. Well, if I divide top by 2, I have to divide both pieces. Gets rid of that 2 in front of the root 57. And when I divide the bottom by 2, it comes out to be 1. So there's my answer right there. 8 plus root 57 and 8 minus root 57. Okay? All right, what else you got? 4x squared? Is this to be done by the quadratic formula?
Yeah.
Okay.
Minus 8x plus 1 equals 0.
Again, I instantly know that I cannot factor this and produce 8 as a middle term, because the best I could possibly do would be this. There's only one set of factors for the number 1, and that does not even get you close to 8. That gets you to minus 5 in the middle. Okay? So again, just how you tell whether something is factorable or whether you have to use the quadratic, it's worth knowing that. So, tell it to me again. Or fill in everything. Now, notice in this step, it doesn't matter whether it's negative 8 squared or 8 squared, does it? Well, negative 8 squared is positive 64, and positive 8 squared is positive 64. So you can avoid having to write that out in that much detail and just write 64. Now, I'm sorry, what? It is. That b squared is always going to be positive. Anytime you take any number, it's always going to be positive if you square it, whether it's negative or positive. And then over here, we have the 4 goes there, that's A, and 1 goes there. And then we have 8 in the bottom. You with me? Simplify the top. Minus 16.
Oh, sorry. Yeah.
So 64 minus 16 is 48.
And then over 8.
So that is at the moment our answer. But is this thing divisible by 4? Okay. Is it divisible by anything larger than 4? In other words, it's helpful if you can actually pick the largest thing that it's divisible by. In other words, if it's divisible by 4 and that's not the largest, then this thing's going to have to be simplified more.
Okay. Well, it's divisible by 8.
Well, that's not a perfect square number. So that doesn't help. In other words, square root of 8 times square root of 6 doesn't really help us much.
Okay.
But it's also divisible by 16, notice.
Okay.
It's root 16 times root 3, which simplifies to what? Root 16 times root 3 becomes what?
Would it be 4 root 3?
Yeah. In other words, you can always do these the same way. Up here on the right, I'm always going to do this like this. That's your first step. Separate it into 2 different radicals, one of them being a perfect square number. Now, just convert that part of it to a 4, leaving that. Okay? Now, it's still all over 8, which means there's one last simplification we can make. What is it?
Dividing it by 8.
You can't divide both parts of the numerator by 8. You can divide it by 4, but only 4. Or 2, but you want to divide top and bottom by the biggest thing that will divide evenly into top and bottom.
Okay.
Okay, and that's 4. In other words, I'm going to divide this thing by 4, I'm going to divide this thing by 4, and I'm going to divide the bottom by 4. And that's your answer. I can no longer simplify that anymore.
Okay.
Okay? I could change it a little bit. In other words, that's also equal to 1 plus or minus 1/2 root 3. So that would be an acceptable answer, is all I've done is turned it into 2 fractions.
Right.
And you don't normally do that. In other words, this is a typical looking answer from a quadratic, so we kind of leave it like this. Unless you're doing like a computer test and they specifically ask for both answers separately, then it's good to know that this means 2 plus root 3 over 2 or 2 minus root 3 over 2. So here's your 2 answers. A lot of times people will deal with that plus and minus for years without realizing that that's what it means. Okay? I have a 5 o'clock that I have to go to. We do have 3 minutes. If you have a quick one, we could maybe get started on it. Or if you have something of another type, I think you got the quadratic formula down correctly now. I could give you a bunch of radical numbers to see if you can simplify them correctly. You want me to do that for 3 minutes? Anna?
Yeah.
Okay. Simplify that. Notice that it's root 5 times root 10, right?
Right.
But also notice that doesn't do any good. Neither of those is a perfect square number. So I don't want to do that. Can you factor 50 where one of the factors is a perfect square number? Let's talk about factoring a number. Okay? When you're factoring a number, start out this way. 50 times 1. Next step, try to cut this in half, which I can do, which means I got to double that. You with me? Next step, I cannot cut this in half or a third, but I can cut it in fifths, which means I have to multiply this by 5. Those are all of my factors of 50. Which two am I interested in?
25 and 2.
Yeah, so it's root 25 times root 2. Always do that step, maintaining both radical signs. And then take that to 5 root 2. Okay? So how about root 200? Root 100. Don't forget that root. It's very important to put radical signs under both factors. You don't want to forget it.
Okay.
Now what?
That,
yeah, 100. It becomes 10 root 2. Okay? In other words, you always want to find the biggest factor. I could have also factored that root 25 times root 8, which works, which gives me a 5 out of that, but root 8 is not simplified. I would have to keep going. So you can always simplify these radicals quicker if you spot the greatest perfect square factor. All right, Anna, I'm going to have to run.
Okay.
Well, I'm glad we got most of the session in at least.
Yeah, sorry about that.
That's all right. I'll talk to you on Wednesday.
All right, thank you.
Bye-bye.